Hey guys, I just wanted to show you how to hook up a simple push button using the Arduino. Now, what I have hooked up right now is just the simple LED circuit. From pin 13, I'm connected to my LED through my resistor, and then this blue rail is connected through the black wire back to ground. So that's a LED circuit you've hopefully put together a dozen times by now. One way I just want to mention, it's a good idea to check and see that your LED works before you try to hook up everything else. So I'm going to move this red wire temporarily over here to the 5 volt output on my Arduino. So that's the one marked with the F5V. That's just going to verify that my LED works. So if I put together my circuit and there's something wrong with it, at least I know my LED is not burned out or something like that. So let me plug this LED back into pin 13. And of course, this is just the simple code for turning on the LED. So if I upload this code to my board, it should just leave the LED turned on. So again, this should be old news by now. Let's look at how to hook up one of these little push buttons. The push button, the way it operates is these two pins along the side are an open circuit until I push the button. An open circuit means no electricity can flow between those two pins. When I push the button down, it closes the circuit and lets electricity flow. So I'm going to move it down just a little bit. So the way this button works is that I'm going to use a digital pin on my Arduino. In this case, I'm going to use pin 2. I'm going to hook that up to one side of my button. And I'm going to hook the other lead of the button up to ground. And so what this means, while this button is not being pressed, there's no electricity flowing through this button. But when I press this button, electricity can flow from pin 2 through the button into the black wire to ground. And what that means is that this pin 2, if I'm running this as an input to my Arduino, I'm going to read that low voltage. That remember, ground stands for a low voltage in my circuit, so that's the lowest voltage that my circuit can achieve. And so when I'm pressing this button, I should be sensing a low voltage through the Arduino. Now, when this button's not being pressed, what I'm going to do is use a resistor. So I'm going to connect one into my resistor to the same row that's plugged into pin 2 on my board, plug the other into the resistor up here somewhere, and then I'm going to connect the resistor to the 5 volt line on my Arduino. And so what this means, when this button is not being pressed, no current can flow across the button. The only path for electricity to flow is from pin 2 through the resistor up to this 5 volt line. And so while this button is not being pressed, the only signal that this input 2 can read is this, well, what's connected to 5 volts. So if the button's not being pressed, pin 2 is going to read a high voltage signal. When the button's pressed, it's shorting out this circuit. Remember, electricity is going to choose the path of least resistance to travel, so it's not going to choose to travel through the resistor. It's going to choose to travel through the black wire to ground. So when the button's pressed, I should be reading a low voltage on pin 2. So that's the simple connection for the button circuit. And I'll tell you right now, like this LED circuit, this button circuit, they're really two separate circuits that I'm putting together. What's connecting these two circuits and making things happen when I use my input to change an output is what we program the Arduino to do. So let's take a look at how we could code this button to work now that we've got it hooked up, hopefully correctly. I'm going to create a variable up here. Just like we made the LED pin variable to specify what digital input-output pin we're connecting the LED to, I'm going to create a, let me call it a sensor pin variable. Now this is just going to specify that I'm connecting to pin 2 on my Arduino. Inside the setup function, I do need to set this pin up. But unlike, I'm still going to use the pin mode function, and here I'm going to set up sensor pin. But instead of setting that up as an output, so that output's like lighting up a light, turning on a motor, twisting the servo, I'm going to set this up as an input so that that digital input-output pin, in this case operating as an input pin, is waiting for a change in this electricity flowing to the pin. So I'm going to specify that to be an input. Now, I need some way of reading that input. Now we know digital write, like if we hook that up to the LED, I can send a high or low voltage signal to whatever numbers in this first argument to the digital write function. What I'm going to do to read a value from the sensor pin is use the digital read. And so the command is just digital read, LED pin, and that will get whatever value this LED pin has, whether it's high or low. Now, I could use this digital read value just like a number. It's going to be a little more convenient if we create a variable to store the results of this digital read in. So I'm going to create an integer called VAL for value that's going to read what's connected to not the LED pin, but the sensor pin, and store that in value. And now I can use that value anywhere in this loop function. And so the way I want to test this button circuit, when we think about what we want to do, if it's not being pressed, I want my LED to turn on. If it's being pressed, I want my LED to turn on. Right now, the code that's loaded up just going to leave the LED on. So I'm just kind of describing what's happening with the circuit. I'm using this word if. So what I need in my code is this if conditional. And so the keyword's if, and you put your condition in parentheses. And the condition I want to check is what this value is equal to. And so to test what something's equal to, it's this double equal sign, whereas a single equal sign here, that assigns a value to a variable. So this is going to test whether two things are equal. So I want to see if value is equal to low. Remember what I said, if the pin here is reading a low voltage, that means I'm pushing this button to close the circuit, so current's going to flow from pin 2 to the ground pin. So a signal of low means that my button is being pressed. So let me put my little squiggly brackets there. What I want to happen when that button is being pressed is to turn my LED on, which is what this little chunk of code is here. I'm just going to move that in between these curly brackets. I'll move this guy back up here because that's where I like to put him. And so that will turn my LED on. Now, there's only one other case with this push button. I'm either pushing it or I'm not pushing it. So in this case, if this corresponds with pushing the button, since the only other thing that could happen is the button not being pushed, I can use an else statement to describe what happens if the button's not being pushed. And I want to do pretty much the same thing. I'm just going to copy and paste this code here, except instead of writing a high voltage signal to the LED, here I want to send it the low voltage signal so it turns off. So, kind of reading this code over, it says if the value is equal to low, so if the button is being pressed, this is going to turn on the line, turn on the LED, I wait for 100 milliseconds, else, otherwise, I want to turn the LED off, and of course this corresponds with the button not being pressed. So, let's see if this works. Verify your code, hit upload. We'll see what happens. Alrighty. Make sure you spell things correctly. Now I will say one thing about these push buttons. It's hard to tell with these buttons in particular whether they're oriented the correct direction. If your button's not working, you can always try rotating your button 90 degrees and see if it works then. Let's see. Looks like I've got my red wire plugged into the ground instead of the 5 volts. So that's why it was always on. Okay, now I think I've fixed my circuit. The button's not being pressed, so the LED is not turning on. I press the button, the LED turns on. I stop pressing the button, it turns off. So that's the basic behavior I want from one of these push buttons. From here, if you want to add more buttons to this arrangement, we're pretty much doing the same circuit, except repeating that somewhere else. For however many buttons you want to hook up to this thing. And we can create as many sensor pin variables as you want. So If you want to add a second button, maybe create sensor pin 1 as a variable and make another variable called sensor pin 2. And so you can read the input of those buttons separately and do whatever you want just using these if then else statements. So hopefully that helps. As always, let me know if you have questions.